Hello everybody, welcome back to another video, and today we're going to be looking at a quite large problem, as you can see right here. Or you can call it kind of small because there's a negative sign. But let's jump right in. Alright, so you are reading this correctly, ladies and gentlemen. You can see that 1 plus 2 plus 3 plus 4 plus 5 all the way on to infinity is equal to negative 1 over 12. This makes absolutely no sense. How does something that is positive and being summed up for infinity, or an infinite number of times, equal something negative? Absolutely super illogical. But if you're vaguely familiar with mathematicians, I'm sure you've heard of Ramanujan. Now, Ramanujan is a legend in mathematics. We consider him as an absolute crazy guy. He did some amazing things, and we use a lot of his work today. So yeah, one thing that he did is on some Sunday night when he was bored, no, I'm kidding, he managed to prove that this is true, using some seemingly questionable methods, but we're going to be taking a look at his proof today. All right, let's get started. So I'm going to be calling this sum equal to S1. Now, for the purposes of the proof, what Ramanujan does is he says, let's define S2 to be this sum, 1 minus 1 plus 1 minus 1 plus 1 dot dot dot. Now, let's say I stop the sum right here, so it becomes a partial sum. That means I summed up these numbers right here, and I'm not going to care about the rest. But this is not equal to the all of S2, of course, because it goes on for an infinite number of terms. If I stopped right here, though, my result would be 0, because this cancels. Now, let's say I made my partial sum stop here instead. What would this equal to? 1. So previously, our partial sum stopped at 0 here, and then it stopped at 1. So our mathematicians are confused. Should we say that this sum is equal to 0, or should we say that this is equal to 1? So there's been a lot of debate over this, and people say it has no value, but there's something called a Cesaro summation, and it's a well-known trick. And if the partial sum differs and oscillates between these two values, similar to how it is here, like 0 and 1, mathematicians claim that this sum is equal to the average of the two, which is 1/2. So for the purposes of the proof, you can debate this in the comments, of course, feel free to, but we're going to be saying that this is 1/2, just for the proof, all right? And yeah, okay, moving forward, let's say S3. So we're going to define another sum called S3, and this will be the last sum we need, if I remember it correctly. But S3 is going to be equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus dot dot dot. So let's think about this for a second. If you have that's not a number line. If you have a number line like this, let me do blue. And this is 0. When we say 1 minus 2, that means we're going to jump back 2, so a negative 1, plus 3, just like this, minus 4 plus 5 plus minus 6 plus 7. So we're essentially oscillating as we get larger and larger between values like infinity and negative infinity. As we get infinitely large, it's going to be jumping back and forth. So what is this sum really equal to? Now, this is when things begin to get a little bit strange. So with this S3, let's say I add S3 to itself. I'm going to write S3 again, but I'm going to rewrite it in a funny way. I'm going to say this is 0 plus 1 minus 2 plus 3 minus 4 plus 5 minus 6. This is valid because it's this exact same sum, and I just added a 0 right here. I just aligned it up a little differently. So, ladies and gentlemen, if we add these two sums, what begins to happen? On the left-hand side, we have 2s3 is equal to what? I have 1. 1 plus 0 is 1. I have negative 2 plus 1, which is minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, plus dot, 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 or minus dot, dot, dot. Just like that. Does this look familiar? Does it look like we've done this in the past before? Yes, we indeed have. We just said that this sum of 1 minus 1 plus 1 was alternating. Using the Cesaro trick, we can say that this is equal to 1/2. So with this logic now, we can say that 2s3 is equal to s2. And s2 is 1/2, so I'm going to bring that down. I'm going to switch colors. Okay, let's try this equals 1/2. So 2s3 equals 1/2 because it becomes that alternating series. So what does that mean for s3? That means s3 is equal to 1/4. So we just talked about this, but on the number line, we said this 1 minus 2 plus 3, this is jumping, we're jumping back and forth, we're jumping like this and this and this and this, and we're saying now it's equal to 1/4. How does that make any sense? That doesn't really make any sense to me the more I think about it. But even if you're skeptical of this 1/2, let's say that we said this partial sum was equal to 1 then that would mean this is a 1, this is a 1, and 1 divided by 2 is 1/2. So there's something funny going on here, because then the sum becomes 1/2, which still doesn't make sense. And if we said that the sum is 0, then that means this entire oscillation between negative infinity and infinity converges to 0. Who knows? Well, that's kind of the beauty of mathematics. Maybe it all cancels out, but who knows? So for the purposes of this proof, using the average, which is like the most satisfying answer, because you don't know if it's 0 or 1 here, and you plug that in accordingly, you get S3 equals 1/4, which is essentially 90% of the way there. Now, if we consider our original sum, S1, I'm going to bring that down here. I'm going to use purple. Why not? Okay, let's say S1 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus ... right? So what we're going to do is we're going to subtract our alternating series, which is the one we did right here, which is S3, from S1. So if you didn't catch that, S3 is equal to 1 minus 2 plus 3 minus 4 plus 5 minus ... Just like this. And we solve for that right now, but we're going to get to that in just a second. So by plugging this in, or by subtracting, if we say S1 minus S3, what does this really mean? Okay, let's take a look. So we're going to have equal to 1, maybe I should stick with one color. Let's try green. This is equal to our first sum, 1 plus 2 plus 3 plus 4 plus 5 plus ... minus 1 minus 2 plus 3 minus 4 plus 5 minus ... We just did that. So all we're doing is simply plugging in right here, and then we plug in S1 right here. So I should delete this arrow. If we say S1 is minus S3, like this, we notice a pattern begins to arise of cancellation. And let me quickly explain what I'm saying by that. What I mean is, if you look at the 1 right here on the left-hand side, part of the sum, this cancels with this one because we're subtracting. Now, this 2 right here, this plus 2, that becomes a part of this 2. So we add that to the 2 over here. This is equal to 4. Now, what happens to this 3? This 3 and this minus 3 cancel. Now, we add 4 to this 4. Then we get plus 8. Then the 5 and 5 cancel because we're subtracting. So we begin to notice a relatively quick pattern, which is going to look like this. And that means S1 minus S3 is equal to 4, if I factor 4 out, 4 times 1 plus 2 plus 3 plus 4 plus ... Now, what do we say that this is equal to? We said that that is equal to our original sum S1. So that means S1 minus S3 is equal to 4 times S1. Now, this is looking quite strange. So let's see for a second. What do we say S3 is equal to? S3, by calculating the sum, is 1/4. That means S1 minus 1/4 equals 4S1. Now, S1, no, so all we're doing is just solving for S1 now, because that's their entire sum. We get S1, we subtract this on this side, like this. Then all we get is 3 times S1 is equal to -1/4. And ladies and gentlemen, with that, we have S1 equals -1/12. If you have any questions, definitely let me know in the comments down below. I'm interested to hear your thoughts on this one. Very interesting sum, Ramanujan, I must say. I'm very shocked on how you would think of that. But yeah, I also want to say I'm very grateful for you guys for subscribing and liking my videos and watching them. We've come a long way. We started out with literally like 10 subscribers, and we're already up to 400 plus. It's really amazing that we have a community of this, and I really appreciate your guys' support. Thank you guys. Leave a comment. Let me know for future videos. See you guys.